So yesterday we were using the unit circle to find these missing the points that were on the unit circle. And so if we go to look at the unit circle, we're on page 571. If we went to page 570, you couldn't find either one of those because 3 pi isn't on there, negative 3 pi, and neither is negative pi over 4. But we could use changing it from radians to degrees to figure out what that angle is. So we took negative 3 pi and we multiplied it times 180 over pi because that's how you go from radians to degrees. And when you multiply that, the pi's cancel because there's one on top, one on bottom. And we multiplied negative 3 times 180 and we got negative 540. So then to figure out what angle on the unit circle that corresponds to, we can go back to page 569 and see which angle it applies to. So we have negative 540. So the unit circle, negative 540. Of course, all angles start on the positive x-axis. Negative means that the side rotates clockwise. So if I go all the way around in a circle, it's 360. If I go 90 more, 360 plus 90, that's 450. It's negative 450. And if I go 90 more, that's negative 540. So negative 540 lands right here at 180, or the radian for that would be pi. So we can go back to our picture, well, not our picture, our problem. And we have, there we go. We have negative 2 times the cosine. Instead of negative 540, we can say that's the same thing as radians, or pi radians. And then to do cotangent, negative pi over 4. Well, yesterday we took negative pi over 4 and we changed it into degrees. So that's negative 45 degrees. If you look like this, there we go. Negative 45 means that it goes clockwise, so it's going to rotate this way. So there's negative 45, because remember we learned it was 30, 45, 60, 90, and then you keep adding those numbers over and over again. So I'm going this way, that's negative 45. Negative 45 corresponds to 7 pi over 4. That's what it is in radians. Okay, so 7 pi over 4 is right here. So instead of negative pi over 4, I can say, oh, that's the same thing as 7 pi over 4. Okay, cosine of pi. So now we look at the unit circle. Now all of these are actually on the unit circle. since I went back and found them. So cosine is which coordinate? According to this up here. Which one is cosine for a unit circle?
X.
Yep, thank you. Cosine is x. So if we look at pi, the x coordinate is -1. So the cosine of pi is -1. And then the cotangent of 7 pi over 4, according to this, cotangent is x over y. So cotangent of 7 pi over 4, that's this point. So here's the ordered pair. And it's negative square root of 2 over 2, and, or positive square root of 2 over 2, and negative square root of 2 over 2. So it's x over y. That is square root of 2 over 2 over negative square root of 2 over 2. Which is the exact same number on top and bottom. So that really just is 1. So you have positive 2, and then -1. All that just to get a 1. Okay, so somewhere on a separate sheet of paper, we're just going to deal with the back side of this, which are all the signs of sine, cosine, tangent, all that stuff. There it is. Okay, so we know we got x, y axes. We have, this is the first quadrant. We have the second quadrant. The third. And the fourth. And that's in the center. So to just get to some random point out here, whether it's on a unit circle or not, it really doesn't matter. We know to get to this point, x and y, I have to go to the right x and up y. And then, of course, the radius is just the radius of the circle. When you do sine, cosine, tangent of all of these, since both x and y are positive, here's your angle, this is your opposite side, this is your hypotenuse. Since all of those are positive, all of my trig functions should be positive. So sine, cosine, tangent, all of them should be positive. If I move it, and I'm going on this side, anywhere in the second quadrant, I have to go to the left x. So that means when I go to the left, my x is going to be negative. But I'm still going up to get to y, so my y is still positive. So here's my adjacent side, my opposite side, and of course my hypotenuse. So tell me which function, sine, cosine, or tangent, is going to be positive. Over you got SOHCAHTOA. Sine would be, because sine is opposite over hypotenuse. And opposite's positive, the y is positive, and the hypotenuse, the radius is always positive. It's a radius. But cosine wouldn't be, because cosine includes the adjacent side. And it shows here that adjacent is negative because I'm going to the left. And same thing with tangent. Tangent has an adjacent in it, so it's going to the left. So the only one positive here is s, sine. Just so I don't get that super crowded, I'm going to draw it again over here. No, r is not positive.